If a single-player game can be finished and forgotten pretty often, then at the same time a well-developed multiplayer can be played for decades. So let's take a look at how multiplayer works from the inside. Hello there, developers! In this video, we will fundamentally understand the structure of online games and how multiplayer works. First, we'll see what implementation of multiplayer games are and what is needed for their work. The next topic will be about the difference between client and server, how server logic works, and how to prevent cheating. Then we'll talk about data transfer packets, how the internet works, how information is transmitted, and also we'll touch upon domain names. And analyze the types of connection methods in online games. Ways to solve these problems, and in general, on what basis the connection between people in the global internet is carried out. And finally, we'll chat about how to create online games and optimization. Types of multiplayer implementation. Game on single device where there are more than one player. Can be racing, where the screen is divided into two parts and the game is controlled from two controllers, or fighting games where two characters are on the same screen. Dynamic single player. Single player game with simple online features like player stats, high scoreboards, share buttons, and other social stuff. Asynchronous multiplayer. In such a game, you sort of compete with a virtual copy of another player controlled by AI, loading information about the opponent from the database, for example, his HP, damage, and appearance. And imagine your opponent doesn't control his character directly. Such data needs to be stored and processed somewhere. As an option, you can use paid or free web hosting to create MySQL database on it and work with it with SQL queries, CPP methods, C# or any other language. And if this is a very plain browser 2D games, then you can just put it into the host folder via FTP protocol. Actually, hosting services don't like this because it takes a lot of traffic and server resources. Such a server can be installed at home, but it makes a lot of noise, requires uninterrupted power and stable broadband internet, and it's pricey though. To get rid of noise, these servers are placed in a special immersive liquid that doesn't conduct currents. You can rent such a server in a data center, or you can rent part of its resources, or give your server to the data center and pay for its maintenance there. An alternative is cloud services like a Google Play Games. The next implementation is turn-based multiplayer. An example is online chess. The opponents are in the game at the same time. After the move of one of the players, a data packet is sent to the other. That is, not every frame of rendering. To implement such multiplayer, you may need a simple database to store achievement statistics and a simple game server that will be a third-party referee, making sure that players play by the rules. A referee duplicates the game on his side, takes sections from the game of one player, checks with his own, and sends it to another. Finally, the next most advanced real-time multiplayer. Here, the exchange of information between players can occur almost every frame, that is, 30 or more times per second. This is relevant for action games with 32 slots or higher, or in MMO games where the number of players is unlimited. It all depends on the performance of the server. Here, thousands of players can take part in one game session. Massive multiplayer online games, MMO for short, the world is constantly saved and exists all the time. In matchmaking, it exists only for one session. To implement this kind of multiplayer, a more powerful game server is required because here the player's actions are performed really often. We will analyze the game server in detail later in this video. You may also need a database for statistics of achievements, of course, if there is such a need. Also, it needs a server list so that players can see the general list of servers. Here you can add matchmaking, automatic selection of players by rank from which a lobby is formed and the game begins. You can implement such services using your solutions, which will work separately on your dedicated server. It all applies to the game's backend. The backend is the logic running on the server side, and the frontend is on the client side. The last four categories can be applied to online multiplayer, because there is some kind of link with the outside world. An alternative way to realize multiplayer is to use cloud services to implement the game's backend. Here are some of these. Google Play game services. Apple also has its own online services. Game parks. Epic Online services. Unity also has this. And Steam Online services. Such services provide many ready-made solutions: matchmaking, events, lobbies, rooms, chat, virtual things, integration with social networks, and so on. Of course, this is not a complete list, there are a lot of them. Backup, Pause, Firebase, PlayFab, and many more among them. There are paid services and free ones. To use these services, you need to integrate their API into your game. The previously listed services are more intended for data, and the server code itself needs to be uploaded to a dedicated server. In fact, the server is a special version of the game for which mechanics are calculated, and in this game there are no visual or sound effects. Types of online connections in multiplayer. The interaction in online games is based on the client-server model. The game logic is divided into two entities. The first is the client. This is the player's computer, which calculates all the important things for the gameplay: visualization of the game graphics, special effects, playing animations. All bone movements in the animation are calculated on the player's device. The server sends the player only a link to the desired animation. The second entity in this system is the server, the computer on which our game exists. It receives information from the client, calculates it, and returns it as needed or hides it altogether. How this could work? For example, the client player wants to move around the map. He presses the key to move, some logic works, and the coordinates in the global space of the character change. These coordinates are immediately sent to the server. The server checks if the player can go there, if there are no obstacles, and if not, then it sends back to the client permission to move, and also sends information to other players that one player moved, and moves a copy of this player to all other players. And such exchange of information between the client and the server happens almost every frame, but there is one important moment. Theoretically, player can send to the server incorrect coordinates using cheats. To avoid this, the developers limit the client, and already in these situations, the client sends the server only input data. Which keys were pressed or held. The server receives this and begins to move the player, and passes them to the player, telling him where to place them. The client can only send data to the server, and the server both receives and sends. The client must not have access to server variables, otherwise he will be able to use cheats. For example, the calculation of remaining ammo should be made only on the server, otherwise the player can build a large number of it. Of course, this is only conventions. No one forbids you to calculate ragdoll on the server and then send it back to the client for better synchronization, or calculate ammo on the client. It's your right as a developer to decide what happens and where. In fact, the essence of interaction is simple. The client must fully copy everything that happens on the server. That is, the server must replicate the data to the client. The processing of data on the server and further sending them to the client is called replication. Remember this word. You can replicate variables, events, components, classes, physics, of course, and particles with animations, but you understand what kind of ping it will be. So, in a game with 2 players in general, we have 6 players, that is, 6 copies of players. 2 for the first player, that is him and a copy of the second. For the second as well, this is him and a copy of the first. And 2 copies on the server. Accordingly, if there are 3 players, then these are 12 copies. Data transfer. Client-server data packets are transmitted over the TCP/IP protocol. When transmitting information from the client to the server, the data is divided into small fragments, and then this information is encapsulated into data packets. They are divided into such fragments for safer transmission because if one fragment is lost, then it's no big deal, but if the whole huge file, then you have to resend it. And then before sending, one side asks the other, "Can I send you files?" Upon receiving a positive response, transmission begins. A two-way communication is called a session. Such packets are transmitted through the TCP/IP protocol stack. A protocol is an instruction that describes how data is transmitted from a source to a destination. It's how data should be packaged, processed, transmitted, routed, and received. The data packet can be described as an envelope with a letter. The address of the sender and the address of the recipient are usually written on the envelope, and the letter itself is inside. The same goes for data packets. It consists of information, all the sent variables, and of the header, which contains the IP addresses of the subscribers. Alternative to TCP protocol, UDP. TCP is slower but more reliable, while UDP is faster but not as reliable as TCP. Less reliable because it doesn't ping the recipient as often, which may cause some packets to fail. And this is what the intercepted packets look like from the inside. UDP is well suited for video streaming and voice communication, and TCP for banking, transaction, or authorization. IP is the Internet Protocol. IP address is the network address of the subscriber's device. Usually it's computer, but only data packets aren't transmitted from computer to computer, but from an application, one computer, to an application on another. In the case of multiplayer games, such applications are a game client on one computer and software server on the another. Such an address of running an application on a computer is called a port, and it's written at the end of the IP address after the colon. The combination of IP address and port is called socket. The digits of the IP address can be replaced with words by entering some name there. It's called a domain. Then the data packet passes through the so-called DNS server. DNS server determines which IP address the domain belongs to. It's like phone book. And then sends to the corresponding IP address. Domain names are .com, .net, etc. This is a domain zone. Everything on the right side is the first-level domain, also known as the top-level domain. What goes to the left on the point is already a second-level domain, and so on through the hierarchy. To the left is a third-level domain. It's also called subdomain, but you have to pay for such domain name. You can reserve a domain through an intermediary company. On average, it costs $10 per year. It's more suitable for size or for convenience. You need to pay for a second-level domain, as you can connect as many subdomains to it as you like. Therefore, you can often find many free third-level domains on the internet. There is even a special service called noip.com. The time of transmission and processing of information is called latency or ping. It's measured in milliseconds. It's usually somewhere between 20 and 200 milliseconds. The multiplayer engine can by default send update data 30 times per second, which is usually less than FPS of the players. This is called PDV, packet delay variation. In order for the game to be synchronous, the engine interpolates this data as if predicting further behavior. Implementation types of the client-server connection. Players can connect to each other directly, so-called peer-to-peer, but since there are kilometers of wires stretched from the one player to another on the way of which there are many switches and routers, there would be big delays. Besides, you can cheat. Therefore, usually in such a bundle, one of the players acts as a server. Such a player on whose computer the server is running is called a host, and the players who connect to it are peers. This kind of server is called a listen server. The game works as a server hosting an online multiplayer session. The host accepts information from remote clients and has local players. Accordingly, this type of server is not very productive, and it's unlikely to pull a large number of players and logic. This mode is often used for casual, cooperative, and competitive online games. The player who is the host has zero ping. Listen server is not very suitable for mobile games because it's unlikely to be able to host the server on a mobile device. In case of loss of connection with the host, the game may be interrupted and then all players will be thrown out of the session. Or host migration can occur. The transfer of the server to another client. And the second is a dedicated server. The game also acts as a server that hosts an online game multiplayer session, accepting connection from remote clients. But there is no local players. Therefore, the server refuses graphics, sound, effects, animation, and other things that work for the client. This mode is often used for games that require more stable and secure connection. Serious online shooter and MMO. Dedicated server can be run separately on the player's computer or on a separate powerful server somewhere in the data center, where is a powerful processor, a lot of RAM, and there's a simple discrete video card plus a wide line of internet connection. On such computers, a server program is launched in the form of console, where logging takes place, that is, the output of events on the server. Management of such a server is carried out by entering server commands. Also, such a server can be with a graphical shell interface. There is also listen peer. These are several listen servers that collectively interact with each other for simultaneous calculation, kind of alternative to a dedicated server. Connection. Now let's talk about the problems that you may encounter when starting the server on your computer. Gray IP. With the obsolescence of IP version 4, there were not enough IP addresses, and many providers deprive users of a permanent IP, giving them a gray IP. For a correct connection, you need to have a wide IP. Wide IP is routed on the global internet and you can connect directly through it. And gray is allocated by the provider. One such IP address may have different owners. Let's find out how it works. We have conditional for computers connected to the same provider. They all use an internal IP, which is also called gray. And there is a common global internet in which the gray IP is not visible. And also on the provider side, there is a NAT device which conditionally has one external, but also a wide IP address. This wide IP address is already available from the global internet. And so, when computers from the internal network want to connect to the external one, the NAT device converts the internal IP to an external one. In such scheme, IP can be static and dynamic. Static is when the number of internal and external IP is the same, and the internal IPs of the computer is assigned to the external one. Dynamic is when the number of global, that is external IPs, is less than internal. Here, many internal ones are already assigned to one external IP, and every time the computer is turned on, the user receives a new freed internal IP. When accessing to the global internet, the NAT device looks to each external IP, the internal address is assigned. The usual static IP is entered manually in the settings of the network card, and the dynamic one is sent automatically every time you turn it up. The DHCP protocol is responsible for the distribution of local IP, a common option for connecting through NAT when one global IP for all internal ones. This is called masquerading. In all cases of placement on the global internet, the external IP is assigned a randomly generated external port. The maximum value of a port number is fixed at 65536. This is how the uniqueness and economy of version 4 IP addresses is obtained, because there are only 4 billion of them. NAT is like city router that creates a local area network in the healthcare sector, and these regions are interconnected in a common global internet using wide IP addresses. Also, many providers deprive users of open ports. They need to be open. For this, you may have to negotiate directly with the provider and possibly even pay extra. If you have a router, then incoming ports may be closed in by default. To open them, you need to go to the router settings by entering the local IP in the browser line and open ports to the server there. To find out your local IP, you can write ipconfig in the CMD console or in the search. Ports also can be blocked by antivirus and the firewall of the operating system. It's better to disable it, or you can just add the desired port. Connection problems can be solved by virtual LAN technology. You can use Hamachi or Radmin for this. You will receive a closed, secure network that will be not accessible from the global internet. This is more suitable for testing or playing with friends. When hosting is a large multiplayer game, obviously you won't be asking every player to download Hamachi. For a stable connection, you need to combine players into one network. You can use online Steam services for this. You need to connect their API to your online game. Another way is to organize a VPN or proxy server yourself. At its core, this is such an intermediate server that acts as intermediary between user and the target server, organizes a tunnel connection. Hamachi and Radmin VPN works on this principle. If one dedicated server is planned for a multiplayer games, then the server must have a wide IP. Such server that can be rented is called VPS or VDS. Here, the organization of the connection is already on the side of the hosting. Of course, here is no one forbids doing everything on your own, buying your own physical server server, and ensuring the correct internet connection. All the connection problems can help to forget one thing. This is IP version 6. Here you can forget about NAT as a bad dream, but this IP is not available to everyone at the moment. It's used by providers and large corporations. Creation of multiplayer. If you are going to create multiplayer in the game, then it's better to plan the game world in advance, taking into account the multiplayer game. Balance is important. The game level should be designed so that one team doesn't have an advantage over the other. You can't allow some players to capture the point just because it's faster for them to get to it from the spawn. Usually the garbage on the card goes to the wall to minimize visual noise. Balancing mechanics is important, and if there is a prospect of balancing two tanks, you can make one big tank slow and clumsy, but with large supply of HP and great damage. You can also reduce damage per minute, and it must also be taken into account that it will be easy to hit him because he is large. The second one can be made small and fast, making it harder to hit while reducing damage dealt but increasing DPM. Replication is also better to be done at early stage. Think about which logic will be performed on the client side and which on the server side. Project optimization also needs to be carried out from the earliest stages. Implementing networks late in a project is resource-intensive and cumbersome compared to initial planning. To optimize the multiplayer, you need to try to organize the game logic in such a way that the client accesses the server as little as possible. To write the server part, you can use server-side programming languages such as PHP or Python or the Node.js environment. Another more acceptable way to use frameworks like Mirror or Photon. They can be used with the Unity engine. There is also an Unreal engine which has excellent netcode from the start. You can use multiplayer out of the box, so to speak, and just in series of lessons we will step by step analyze multiplayer in Unreal Engine.